So in today's session, we will discuss about the internal architecture of 8086. Internal architecture, or we can say that it is the functional block diagram of the 8086. So as we all know that what is a microprocessor? So generally a microprocessor is a programmable digital device, and which is designed with the flip-flops, gates, resistors and other timing elements. Flip-flops, gates and other timing elements here. So a microprocessor is designed with the digital gates, flip-flops, resistors and other necessary timing elements. And here, since it is the programmable digital device, it has a set of instructions. The 8086 is a programmable device. Therefore, it has a set of instructions, and these instructions are designed internally to manipulate the data and to communicate with the peripherals, isn't it? So the microprocessor is designed to manipulate the data and to communicate with the peripherals. So therefore, it requires the instructions. It requires instructions as it is a device, as it is a programmable device. It requires the commands or instructions. So it has an instruction set, and that instruction set manipulates the data and it communicates with the peripheral devices. So now, what do you mean that the architecture of the processor, or what is architecture of the processor? So how we can define the architecture here? So here, the process of data manipulation and communication is determined by the logic design of the processor is called the architecture here. It is called the architecture. So the process of data manipulation and communication is determined by the logic circuitry of the processor. The logic circuitry of the processor. So that is called the architecture. Okay, that is, you can define it one way. We can define it, the architecture of the processor here. Okay, and then here, so the processor has an instruction set. Because of it is a programmable device, it has an instruction set. So the processor can be programmed. The processor can be programmed to perform the functions by selecting the necessary instructions from its instruction set. So the processor can be programmed to perform the various operations here. It can manipulate the data or it process the data. But so by selecting the necessary instructions, you can perform the operations. And these instructions are given to the microprocessor by writing them into the memory of the processor. So how we can give the give the instruction to the processor? By writing the instructions into the memory of the processor. So the microprocessor reads those instructions, or reads the data from the memory, and generally the instructions or the data can be given to the processor, through the input devices such as the keyboard devices. So therefore, through the keyboard, we will give the instructions, we will give the data, and the microprocessor reads the data. So where do we place the data? So we will place the data, or we will place the instructions in the memory. So therefore, the microprocessor reads the data, or it fetches the instructions from the memory, and then according to the given instruction, it processes the data or it manipulates the data, and then it sends the results to the output devices. So now simply here you can understand the microprocessor as a digital device which receives the data and processes the data and then sends the results to the output devices, right? And sends the results to the output devices. So output devices such as an LED or LCD, or even you can store that result in the memory too, which is also treated as an output in such cases. Okay, so simply the processor receives data, processes the data, and then sends the data. And in addition of these, the processor can also respond to the external signals here. So these are all the internal functions, receiving the data, processing the data according to the instructions, and send the results to the output devices. These are all internal functions of the processor. And now the processor can also respond to the peripheral, I mean that external signals, peripheral signals. So peripheral, the external signals such as the processor can be interrupted. It is one of the external signal, or the process can be reset, or the processor can be asked to wait to synchronize with the slow peripheral devices. So these are the external operations of the processor. So interrupting the processor for to do execute the any other task, and then reset the processor. The processor can be reset. It is being reset here for some purposes and some applications. We wanted to reset the processor, and you can also request the processor to synchronize the slow peripheral devices. How the processor will synchronize the slow peripheral devices? So it will wait for the response of the slow peripheral device, and then it takes the data from the slow peripheral devices, and then it processes the data. So these are the external operations. So therefore, the architecture of the processor determines all these internal operations, external operations of the processor. Even in the functional block diagram also, if you look at the functional block diagram, so which describes about all these operations here. So that's why all the operations performed by the 8086, they can be classified into 3 groups here. One is initiated operations. They are also known as the primarily operations. And the second is internal data operations. And third one is external initiated operations. So these are all the 3 group of the operations, or these are the operations performed by the any processor in general. So if you see the initiated operations, so what are the initiated operations here? The initiated operations are nothing but memory read, memory write, IO read, and IO write. These are all called the initiated operations. You know what a memory read, memory write, IO read, and IO write. Reads the data from the memory is a memory read, writes the data into the memory is a memory write, accepts the data from the input device is a IO read, sends the results to the, or sends the data to the peripheral output device is a IO write. So these are all major or primarily operations: memory read, IO read, IO write. Right? These are all primarily operations. So therefore, primarily operations. So these are all the part of the communication of the process event too. Suppose మీరు మెమరీ నుంచి రీడ్ చేస్తున్నారంటే ఏంటి? వన్ వే యు ఆర్ కమ్యూనికేటింగ్ విత్ ద మెమరీ. మీరు పెరిఫరల్ నుంచి డేటాను తీసుకుంటున్నారంటే ఏంటి? యు ఆర్ కమ్యూనికేటింగ్ విత్ ద ఇన్పుట్ డివైస్. డేటా ట్రాన్స్ఫర్ చేస్తున్నారు అంటే ఏంటి దాని అర్థం? యు ఆర్ కమ్యూనికేటింగ్ విత్ ది అవుట్పుట్ డివైస్. సో దేర్ఫోర్ ద మెమరీ రీడ్, మెమరీ రైట్, IO read and IO write, these are all the part of the communication process. These are all the part of the communication process. So to perform these operations, the microprocessor requires a set of communication lines here. It requires a group of lines. They are called as buses here. So therefore we have the 3 buses: address bus, data bus, and control bus. Actually the control bus is not a group of lines. They are individual lines, but మనం జనరల్ గా చెప్పేటప్పుడు it is a control bus. Actually these are all individual signals. Okay, so to perform the memory read, memory write, IO read and IO write, the microprocessor requires a group of lines. They are called buses. అందుకనే నిన్న క్లాస్ లో కూడా అన్నాను, for any device, for any digital system, for any digital circuit, in order to communicate with the other devices, they must have the buses, address bus and data bus. And you know what is a address bus of processor? The 8086 address bus enti? It is a group of 20 lines. What is a data bus? It is a group of 16 lines, isn't it? And how about the control bus? The control bus is a nothing but it is a comprises of the individual signals. So the major signals are memory read, memory write, IO read and IO write. The major control signals. Okay. Major control signals. And coming to the internal data operations. Coming to the internal data operations. ఇప్పుడు మనం ఏం చెప్పాం, ఎక్స్టర్నల్ ఇనిషియేటెడ్ ఆపరేషన్స్ అన్నాను. ఎక్స్టర్నల్ ఇనిషియేటెడ్ ఆపరేషన్స్ అంటే ఏంటి, పైన మనం చేసేది రీడ్ రైట్ మెమరీ ఐఓకి. కానీ ఇంటర్నల్ గా మైక్రోప్రాసెసర్ ఏం చేస్తుంది, ఇంటర్నల్ గా మైక్రోప్రాసెసర్ 4 ఆపరేషన్స్ చేస్తుంది. ఇట్ విల్ పెర్ఫార్మ్ ది 4 ఆపరేషన్స్. ఒకటి ఏంటంటే ఇట్ స్టోర్స్ ది డేటా. సెకండ్ ఏంటంటే ఇట్ పెర్ఫార్మ్స్ ది అర్థమెటిక్ అండ్ లాజిక్ ఆపరేషన్స్. అండ్ థర్డ్ వన్ ఏంటంటే ఇట్ చెక్స్ ద సీక్వెన్స్ ఆఫ్ ది ప్రోగ్రామ్ ఎగ్జిక్యూషన్. ఎందుకని, మన ఎగ్జిక్యూషన్ కరెక్ట్గా జరుగుతుందో లేదో అన్నది మనకు తెలియాలి కదా. సో దానికోసం ఇట్ చెక్స్ ది ఎగ్జిక్యూషన్ ఆఫ్ ది ప్రోగ్రామ్ సీక్వెన్స్. అండ్ ద లాస్ట్ వన్ ఏంటంటే ఇట్ స్టోర్స్ ద డేటా టెంపరల్లీ డ్యూరింగ్ ది ప్రోగ్రామ్ ఎగ్జిక్యూషన్ ఇన్ స్టాక్. సో దట్ ఈస్ స్టాక్ అంటే డేటాని టెంపరీగా స్టోర్ చేసుకుంటుంది. ఎప్పుడు ఏదైనా ఒక ప్రోగ్రామ్ ఎగ్జిక్యూట్ అవుతున్నప్పుడు మనకు వచ్చే డేటాని టెంపరీగా స్టోర్ చేసుకోవడానికి ఇట్ యూజెస్ ది స్టాక్ హియర్. సో దీస్ ఆర్ ది 4 ఆపరేషన్స్ related to the internal data operations. And what about the external operations? External operations ante intaku mundu manam 3 cheppukunnam gurtunda. Microprocessor can be interrupted, the processor can be resetted, and the processor can be asked to wait or can be asked to synchronize the slow peripheral devices. These are the external initiated operations. మీరు ఈ పాయింట్స్ని కనుక అర్థం చేసుకోగలిగితే ఆల్మోస్ట్ మనం ఒక ఆర్కిటెక్చర్ని డిస్కస్ చేసేటప్పుడు ఎనీ కైండ్ ఆఫ్ ఆర్కిటెక్చర్, ఐ మీన్ దట్ 8086 అవ్వండి, అదర్ ప్రాసెసర్స్కే కానీ దేనికైనా కానీ అక్కడ వచ్చే కాన్సెప్ట్ ఏంటంటే ఇవి ప్రైమరీ ఆపరేషన్స్, ఇంటర్నల్ ఆపరేషన్స్, ఎక్స్టర్నల్ ఆపరేషన్స్. ఓకే, సో జస్ట్ an idea. So I have discussed these points with you. And coming to this 8086 architecture, so here the entire architecture of the processor internally can be divided into 2 functional units. It can be divided into 2 functional units here. It can be divided into 2 functional units: execution unit, bus interfacing unit. Okay, so first we will see what are the functions of these units here. Ante entire architecture ni rendu kinda split chesinappudu వీటి మేజర్ purposes ఏంటన్నది మనం చూడాలి, right? So now what are the functions of the bus interfacing unit? So the functions of the bus interfacing unit, it fetches the instructions or it reads the operands or the data from the memory or from the selected IO ports. Okay, and then it stores the results into the memory here, and then it stores the results into the memory here. Okay, so the bus interfacing unit fetches instructions, reads operands or data from the memory, and then writes the data. After executing the data, it has a result, and the result can be stored in the memory location or selected IO device, here. So these are the 3 functions. So in a simple way lo cheppali ante, okati fetches the instructions. Second function enti, it reads the data from the memory or IO devices. And third function enti, it writes the data to the memory or peripheral devices. ఒకటి ఇన్స్ట్రక్షన్ తీసుకుంటుంది, లేదా రెండోది డేటాని మెమరీ నుంచి కానీ పెరిఫెరల్ నుంచి కానీ రీడ్ చేస్తుంది, మూడవది ఏం చేస్తుంది, డేటాని రైట్ చేస్తుంది దేంట్లోకి, మెమరీకి కానీ పెరిఫెరల్ డివైసెస్ కానీ. ఓకే, దీస్ ఆర్ సింపుల్ 3 functions of the bus interfacing unit. So it is meant for these 3 operations. and second one is execution unit. So here the execution unit is meant for, it receives the program instructions data or code from the bus interfacing unit. Actually, bus interfacing unit em chestundi, it fetches the instructions or data from the memory. So whatever the data which is being fetched, which is fetched by the BIU, they will be received by the execution unit. అంటే BIU ఏదైతే తీసుకొచ్చిందో దాన్ని ఎగ్జిక్యూషన్ యూనిట్ ఏం చేస్తుంది, రిసీవ్ చేసుకుంటుంది ఫర్దర్ ప్రాసెసర్ కి. ఓకే, కాబట్టి ఎగ్జిక్యూషన్ యూనిట్ ఏంటి, BIU నుంచి వచ్చిన డేటా మీద డిపెండ్ అవుతుంది వన్ వే. ఓకే, సో it receives the program instruction codes and then executes the instructions. అందుకని దీనికి నేమ్ ఏముంది, ఎగ్జిక్యూషన్ యూనిట్ అంటున్నాం. సో it executes the instructions. After that it stores the results in the general purpose registers. ఇక్కడ మీకు డౌట్ రావచ్చు, ఇక్కడ కూడా డేటాని సెండ్ చేస్తుంది, ఇక్కడ డేటా సెండ్ చేస్తుంది, కానీ మీరు అబ్జర్వ్ చేయండి, బస్ ఇంటర్ఫేసింగ్ యూనిట్ లో డేటా ఎక్కడికి వెళ్తుంది, మెమరీ లొకేషన్ కానీ అవుట్పుట్ డివైసెస్ కానీ డేటా ట్రాన్స్ఫర్ అవుతుంది. కానీ ఎగ్జిక్యూషన్ యూనిట్ లో డేటా ఎక్కడ స్టోర్ అవుతుంది, జనరల్ పర్పస్ రిజిస్టర్స్ లో స్టోర్ అవుతుంది. అంటే ఇన్సైడ్ ఆఫ్ ద ప్రాసెసర్, ఇట్ ఈస్ నాట్ external to the processor. Okay, so these are the simple functions of the bus interfacing unit and execution unit. Bus interfacing unit and execution unit. So we will conclude for today's session within a 1 minute. Okay, so we will see the functional block diagram and their and its explanation in the next class. Okay, so we will conclude it for today's session. So within 1 minute I will conclude here. Okay, so execution unit. So now can you understand what are the bus interfacing unit functions and execution unit functions? So what are the bus interfacing functions? It fetches the instructions, it reads the data or data from the memory or input devices, it writes the data to the memory or output devices. And what are the functions of the execution unit? It receives the data or the instructions from the bus interfacing unit, then it executes. అంటే అక్కడ నుంచి ఏదైతే తీసుకుందో దాన్ని ఎగ్జిక్యూట్ చేస్తుంది. ఇక్కడ ఎగ్జిక్యూషన్ యూనిట్ లో ఇట్ ఎగ్జిక్యూట్స్ ద ఇన్స్ట్రక్షన్స్. అండ్ థర్డ్ వన్ ఏంటి, ఇక్కడ ఇట్ స్టోర్ ద రిజల్ట్ ఇన్ ది జనరల్ పర్పస్ రిజిస్టర్స్. సో దీస్ ఆర్ ది these are the functions of the bus interfacing unit and the execution unit. So do you understand this?
Yes, sir.
So the next one is the architecture of the 8086. So we will discuss about the architecture. So I will conclude. Okay. So if you observe this diagram here, you have the two parts in the diagram, isn't it? So one is the bus interfacing unit. Look at this. And the second one is the execution unit. Look at this. Right? The entire architecture, it is split into the two functional units, bus interfacing unit and then execution unit. So now each functional unit in turn consists the different functional units. Look at address generation unit, segment registers, instruction pointer, bus control logic, instruction queue. These are all the parts of the bus interfacing unit. Now what are the parts of the execution unit? The parts of the execution unit are the general purpose registers. So these are the general purpose registers. See? And the other registers, pointer registers, index registers, arithmetic logic unit, flags. Okay, flags. So these are all the units, I mean the sub-functional units of the execution unit. Okay, so this is the functional block diagram of the 8086 here. So here you can see the same diagram, right? You can see the same diagram here. So we will discuss about the functional block diagram in the next class. Separately, we will discuss bus interfacing unit and execution unit. So now, we will conclude with the bus interfacing unit. We will conclude with the bus interfacing unit. So now, what are the functional parts of the bus interfacing unit? Now you can identify it here from the diagram. So the same thing I have listed here. Segment registers, I will again show you on the diagram. I will show you segment registers, instruction pointer, address generation unit, instruction queue, bus control logic. So these are the parts of the bus interfacing unit. The same thing you can identify in the diagram also. So see here, these are the segment registers here. So segment registers, instruction pointer, and then address generation unit, bus control logic, and instruction queue. So in the next class, so we will discuss about the architecture. Okay. So if you have any doubts regarding the subject, you can ask me.